Hey y'all, today is Wednesday, September 22nd, and we are working on lesson 2-2. It starts on page 95, so let's get started. Allison and her classmates planted bean seeds at the same time as Yuki and her classmates in Tokyo did. Allison is video chatting with Yuki about their class seedlings. Assume that both plants will continue to grow at the same rate. Who should expect to have the taller plant at the end of the school year? So when we look closely in the picture, it tells us that Allison's class, their plant grows 2.5 inches every 5 days. So we're going to find the unit rate. How fast does it grow in just 1 day? So in order for us to determine that, how fast does it grow in just 1 day, I need my denominator to be 1. So now my question is, how do I go from 5 to 1 using either multiplication or division? Well, that's simple. I'm going to divide by 5. So I'm going to divide by 5 here on the bottom, and I need to do the same thing on the top to keep things equivalent. Remember, we can use a calculator. So when we put into our calculator 2.5 divided by 5, we end up with 0.5. So this right here is our unit rate. And what does it mean? It means that Allison's plant grows 0.5 inches per day. Every day it's growing 1/2 inch. Now let's talk about Yuki's plant. Based on this picture, it grows 5.5 centimeters in 4 days. So we want to know how much does it grow in just 1 day. So we know our denominator needs to be 1. Now again, how am I going from 4 to 1? Well, that's simple. I'm going to divide by 4. And if I do that on the bottom, I have to do the same thing on the top. So I'm going to put into my calculator 5.5 divided by 4, and I get 1.375. 1.375 over 1, that right there is our unit rate. What does it mean? It means that Yuki's plant grows 1.375 centimeters per day. Yuki's plant grows 1.375 centimeters per day. Now, hopefully you notice something that's a little problematic here. Allison's plant grows 0.5 inches per day. Yuki's plant grows 1.375 centimeters per day. We've got 2 different units here. So let's answer this question on Focus on Math Practices. What must the students do before they can compare the heights of the plant? Well, we would need to convert units so that both growth rates use the same units. So we need to convert or change the units so that both growth rates use the same units. In other words, we need for them to both be in inches or both be in centimeters. So right now, we really can't compare the 2 growth rates, and so we don't know who we should expect to have a taller plant at the end of the year because we have 2 different units. Okay, let's move on to page 96. So example 1, find a unit rate involving fractions. Sergio is training for a triathlon. His target speed is 25 miles per hour. Did he achieve his target speed for the first 7 miles of his ride? Okay, so when we're looking at this picture, we see that he biked 7 miles in 15 minutes. Now, what we would have done yesterday is we probably would have said he bikes 7 miles in 15 minutes. And we want to know what is his speed, or how far does he bike in an hour, which is 60 minutes, right? And then we would have said, how do I go from 15 to 60? Well, I multiply times 4. So I'm going to do the same thing on the top. And that would have given us our answer. So we know that 7 times 4 is 28. So 28 miles in 1 hour. But we can actually use fractions in our rates. And the fractions can help us find our unit rates. So I do want to show you that concept as well. Okay, so remember, this right here is what we did yesterday. It still works, but let's look at a new method today. So we know that he's biking 7 miles in 15 minutes. Well, 15 minutes is how much of an hour? It is 1/4 of an hour, or 1/4 of an hour, right? So we're going to use 1/4. So he bikes 7 miles in 1/4 of an hour. So we want to know how much he will bike in just 1 hour. So I want to remind you about the concept of complex fractions. So this really means 7 divided by 1/4, right? So let's write that out. 7 divided by 1/4. And can I rewrite that 7 as a fraction? What would it be? It would be 7 over 1. So we really have 7 over 1 divided by 1/4. Well, remember, keep, change, flip. What do I keep? I keep my 7 over 1. I change division to multiplication, and then I flip my second fraction. So it's going to become 4 over 1. So my question to you is, when I multiply this, what do I get? I get 28 over 1, right? So was 28 what we said? He would bike 28 miles in 1 hour. Yeah, that's exactly what we said just a minute ago. So when I have a setup like this that's a complex fraction, what I need to remember is that in order to go from 1/4 to 1, I simply need to multiply by the reciprocal. And the reciprocal is a fancy term that means I'm going to flip my fraction and multiply. So 1/4 I multiply times 4 over 1. So I had to do the same thing on the top, and that's how I got to 28. Okay? We're going to get lots of practice, so don't worry. But the question here is, did he achieve his target speed for the first 7 miles of his ride? Remember, he wanted to go 25 miles in an hour. And this tells us that he goes 28 miles in an hour. So yes, he achieves his target speed. Okay, moving on to try it. Sergio increases his target speed to 30 miles per hour. How many more miles does Sergio need to ride in 1/4 of an hour to achieve his target speed? Okay, so we're going to start right here with the unit rate. And it tells us that he increases his target speed to 30 miles per hour. So I'm going to write a unit rate with that. 30 over 1. And we want to know how many miles he needs to ride in 1/4 of an hour to achieve that target speed. So we're going to have 1/4 as our new denominator. So my question to you is, how do I go from 1 to 1/4? Well, I'm simply dividing by 4, right? So I'm going to do the same thing on the top. And when I put 30 divided by 4 into my calculator, I get 7.5. So Sergio must ride 7.5 miles in 1/4 of an hour to achieve his target speed. So he needs to ride an additional 0.5 miles per hour. Because remember at the top, he was only biking 7 miles in 1/4 of an hour. So he needs to go an additional 0.5 miles in order to achieve his new target speed. Okay, looking at convince me. How does the unit rate describe Sergio's cycling speed? How is the unit rate helpful in determining how much farther Sergio must cycle in a given amount of time each time he increases his target speed? So let's talk about what the unit rate describes first. The unit rate describes how many miles, the unit rate describes how many miles he bikes in 1 hour. The unit rate describes how many miles he bikes in 1 hour. Now, the unit rate makes it easier to find the distance he must bike in any amount of time. What that means is we could use the unit rate to find very easily how far he must bike in half an hour or in 1/3 of an hour. Once we have that unit rate, we can go up or go down with it. Okay, let's move on to page 97, example number 2. Bronwyn mows the lawn every other weekend. She can mow 12,000 square feet in 2/3 of an hour. The lawn is 36,000 square feet. How long does it take her to mow the entire lawn? So I crossed out some stuff, but we're going to show our work down here where we have some extra space. And it told us in here that it takes her, or she can mow 12,000 square feet in 2/3 of an hour. So we're going to start there. So 12,000 square feet in 2/3 of an hour. Well, we want to know how much she can mow in just 1 hour, right? That would be our unit rate. So how do I go from 2/3 to 1? Do you remember? I multiply by the reciprocal. And what is the reciprocal in this case? It is the same fraction just flipped upside down. So the reciprocal of 2/3 is 3/2. So I'm multiplying by 3/2 on both the top and bottom. And remember, I can use a calculator, but I do want to show you how simple this is. We have 12,000 that I'm going to write as 12,000 over 1 times 3/2. Well, when I look to see if anything reduces, 1 and 3 don't, but 2 and 12,000 do. 2 goes into both of those. So 2 goes into 2 one time. 2 goes into 12,000 6,000 times. So now I just multiply 6,000 times 3, and I know that 3 times 6 is 18, and then I need 3 zeros behind that 18. So it's 18,000. So 18,000 square feet is how much she mows in just 1 hour, right? But that's not the question. The question is, if the lawn is 36,000 square feet, how long does it take her to mow the entire lawn? So remember, The lawn is 36,000 square feet, and we want to know the time it takes her to mow that much lawn. So my question now is, how am I going from 18,000 to 36,000? Either through multiplication or division. That's right, I'm going to multiply times 2. And if I multiply times 2 on the top, what should I do on the bottom? Multiply times 2. That's what keeps it equivalent. So it takes her 2 hours to mow 36,000 square feet. So we can write that out. It takes her 2 hours the entire lawn. It takes her 2 hours to mow the entire lawn. Okay, moving on to try it. Every other weekend, Bronwyn's brother Daniel mows the lawn. He can mow 15,000 square feet in 3/4 of an hour. Who mows the lawn in less time? Explain. Okay, so we're going to use the information provided to us about Daniel. He mows the lawn he mows 15,000 square feet in 3/4 of an hour. We're going to start with that, and then we're going to find the unit rate. So 15,000 square feet in 3/4 of an hour. Well, how much can he mow in 1 hour? Well, how am I going from 3/4 to 1? What am I going to do? Multiply by the reciprocal. So I'm going to multiply by 4/3. And I do the same thing on the top. And I can put that into my calculator, but you really don't need to. We have 15,000 over 1 times 4/3. Well, 1 and 4 don't reduce, but 3 and 15,000 do. 3 goes into both of those. 3 goes into 3 one time. 3 goes into 15,000 5,000 times. Now 5,000 times 4 is going to be 20,000. So 20,000 over 1. What does that mean? That means that Daniel mows 20,000 square feet in 1 hour. So now that we have our unit rates, that's what we want to compare to figure out who mows the lawn in less time. So Daniel mows 20,000 square feet in 1 hour, and Bronwyn mows 18,000 square feet in 1 hour. So who covers more yard? Daniel. So Daniel mows the lawn in less time. Okay, moving on to example number 3. So Omar knows that his friend Chris lives 3/5 mile away. How far is the school from Omar's house? So we've got this little map to help us. And what we know is that Chris lives 3/5 mile away. So this 3/4 of an inch represents 3/5 of a mile, right? So we're going to use this as our unit rate, or sorry, not as our unit rate, as a rate, and then we'll find the unit rate. So we've got 3/5 of a mile is represented on the map by 3/4 of an inch. So I want to know what is the mileage that is represented by 1 inch on this map? So how do I go from 3/4 to 1? That's right, I multiply by the reciprocal. So I just multiply by 4/3. And I do the same thing on the top. So now I've got 3/5 times 4 over 3. And what I notice is that 4 and 5 can't be reduced, but 3 and 3 can be reduced. So 3 goes into both of those, so that 3 becomes a 1, and that 3 also becomes a 1. So 1 times 4 is 4, 5 times 1 is 5. So 1 inch on the map is 4/5 of a mile. Okay, but the question is, how far is the school from Omar's house? And we see on our map that the school is 2 inches. So we're going to use our unit rate that we just found and figure out how much of a mile is represented by 2 inches on the map. Okay, so how do I go from 1 to 2? Well, that's easy. I'm multiplying by 2. So I'm going to do the same thing here. I'm multiplying by 2, but remember that's a 2 over 1. Okay, and you can use your calculator to figure this out, but we know that 4 times 2 is 8. And we know that 5 times 1 is 5, so 8 over 5. So this right here tells us that Omar's house and the school are 8/5 miles away. But that is an improper fraction, isn't it? We can turn that into a mixed number, and it's much easier, much more friendly to read, right? So how many times does 5 go into 8? Well, 5 goes into 8 one time, and then I have 3 left over, so 1 3/5 is the distance. So we know the school is 1 3/5 miles, away. The school is 1 3/5 miles away, and that right there is our answer. Okay, moving on to try it. Sonoma bikes 5 miles to Paige's house. On a map, they measure that distance as 5/6 of a centimeter. The same map shows the mall is 3.5 centimeters from Paige's house. What is the actual distance between Paige's house and the mall? Okay, so we know, based on the very first line, that Sonoma bikes 5 miles to Paige's house, and on a map, that measure is 5/6 of a centimeter. So I'm going to use that information to write a rate. So 5 miles is equivalent to 5/6 of a centimeter on a map. So we want to know how many miles is equivalent to 1 centimeter. So how am I going from 5/6 to 1? I'm going to multiply by the reciprocal, that's right. So I'm going to multiply times 6 over 5. I'm going to do the same thing right here, 6 over 5. So I could put that into my calculator, but just real quick, we know it's 5 over 1 times 6 over 5. My 5's cancel out and become 1's, right? So I'm left with just 6. So 6 miles is equivalent to 1 centimeter on a map. Now, the same map shows that the mall is 3.5 centimeters from Paige's house. So one thing that I'm going to do is I'm going to change this right here to a decimal. So I know that that is going to be 3.5. That just makes it easy for me to use my calculator. So 3.5 is 3.5. So I want to know what 3.5 centimeters on a map is in miles. So how do I figure that out? Well, how am I going from 1 to 3.5? I'm simply multiplying, right? I'm going to multiply times 3.5 on the bottom and on the top. And when I put 6 times 3.5 into my calculator, I get 21. So what does that mean? It means the mall is 21 miles from Paige's house. Okay, moving on to page 98. So we're going to skip numbers 1, 2, and 3, and we're going to work on just the do you know how questions. So starting with number 4. Claire boarded an airplane in Richmond, Virginia, and flew 414 miles directly to Charleston, South Carolina. The total flight time was 3/4 of an hour. How fast did Claire's airplane fly in miles per hour? So what we know is that she flew 414 miles, and it was 3/4 of an hour that it took. So I'm going to use that to write a rate. 414 miles over 3/4 of an hour. And we want to know, what is the speed of the airplane in 1 hour? How fast did it fly in just 1 hour? Well, how am I going from 3/4 to 1? I multiply by the reciprocal. So I'm going to multiply by 4 over 3. And I do the same thing on the top. And when I put that into my calculator, I'm going to get 552. 552 over 1. So what exactly does this right here mean? It means that in 1 hour, that plane would have flown 552 miles. So the speed of the plane is 552 miles per hour. Okay, moving on to number 5. Brad buys 2 packages of mushrooms. Which mushrooms cost less per pound? Explain. So we've got cremini mushrooms and chanterelle mushrooms. And let's start with the cremini mushrooms. They're $11.25 for 2/3 of a pound. So we want to find the unit rate. So we start with 11.25 over 2/3. We want to know, what would that price be for 1 whole pound? So how am I going from 2/3 to 1? Well, I'm multiplying by the reciprocal. So I multiply by 3 over 2. And I do the same thing here. I multiply by 3 over 2. And remember, we're using our calculator. So when I type 11.25 times 3 over 2 into my calculator, I get 16.875 over 1. Now, we're talking about money, right? And money definitely doesn't have 3 decimal points. So because that's a 5 right there, what do I want to do with that 7? I want to round it up. So these cremini mushrooms cost $16.88 per pound. $16.88 per pound. Now let's look at the chanterelle mushrooms. Okay, so they're $7.99 for half a pound. So we're going to use that to write our rate, $7.99 for half a pound. So how much would they cost for 1 whole pound? Okay, well, how am I going from 1/2 to 1? What am I doing here? I'm going to multiply by the reciprocal. So I'm multiplying by 2 over 1, or simply just 2, right? So I multiply by 2. And when I put $7.99 times 2 into my calculator, I get 15.98. So the chanterelle mushrooms cost $15.98 per pound. So the question is, which mushrooms cost less per pound? And the ones that cost less per pound are these right here. So the chanterelle mushrooms are the better deal. And those are the ones that we would probably buy. Okay, moving on to number 6. Jed is baking shortbread for a bake sale. The recipe calls for 1 1/4 cup of flour and 1/2 stick of butter. How many cups of flour will Jed need if he uses 3 sticks of butter? So we've got some information here. We've got enough to write a rate, 1 1/4 cup of flour and 1/2 stick of butter. So I'm going to go ahead and change that mixed number to an improper fraction. 4 times 1 is 4, plus 1 makes 5. So I have 5/4 cups of flour for every 1/2 a stick of butter, right? So I need to find our unit rate. So how much flour do I need for just 1 stick of butter? Well, how am I going from 1/2 to 1? I'm simply multiplying times 2/1, right? So I'm going to do the same thing on the top, multiply times 2/1. And what I notice is I can reduce here. 5 and 1 don't reduce, but 4 and 2 definitely do. 2 goes into both of those. 2 goes into 4 2 times. 2 goes into 2 1 time. So when I multiply across, I'm going to have 5/2. So we have 5/2 cups of flour for every 1 stick of butter, right? Well, but the question is, how many cups of flour will he need if he uses 3 sticks of butter? So, how am I going from 1 to 3? Well, I'm simply multiplying. Oops, let's change that color. Multiplying times 3, right? So I'm going to do the same thing on the top. And if I just multiply by 3, that's the same thing as multiplying by 3/1. So now I'm simply just going to multiply across because nothing reduces here. 5 times 3 is 15. And then 2 times 1 is 2. So I have 15/2 cups of flour for every 3 sticks of butter. Now, 15/2 is an improper fraction. So how can I make that a mixed number? I can ask myself, how many times 2 goes into 15? And 2 goes into 15 7 times. And I have 1 left over because 2 times 7 is 14. So 7.5 cups of flour is what Jed will need if he uses 3 sticks of butter. So that is the end of page 98.